So in this video, we're going to do a quick review on multiplying monomials and binomials. Here are some examples of some monomials that we'll take a look at, and here are some examples of binomials. So let's get to it. So here we go, multiplying monomials. Monomials are polynomials that have just one term. So we are multiplying a monomial times a monomial. So we are simply going to multiply the coefficients together, -6 times 3, and then we're going to multiply the variables x squared times x to the 4th. So that is why the final answer comes out to be -18x to the, and remember rules of exponents. If you're multiplying exponents that have the same base, remember you add the exponents. And that's why the answer is x to the 6th power. So there is our final answer. In problem number 2, notice that we're taking the quantity 4x to the 3rd power and we're squaring it. Remember what that 2 means. That means we're multiplying 4x to the 3rd times another 4x to the 3rd. So again, we're going to multiply the coefficients together, 4 times 4, and then multiply the variables x to the 3rd times x to the 3rd. And that is why our final answer is going to be 16x to the, and again, when you're multiplying exponentials, remember you add the exponents. So that's why this exponent is going to be x to the 6th power. So our final answer is 16x to the 6th power. Number 3, once again, 5x is being raised to the 2nd power. Remember that squaring means that 5x is being multiplied by another 5x. So we are simply going to multiply the coefficients together, 5 times 5, and then we will multiply the variables x times x, and that is why our final answer is 25x squared. Remember that x times x times x is x to the 3rd, x times x is x squared. Obviously, x times x times x times x is x to the 4th, right? Just a reminder. And we could have also said x to the 1st times x to the 1st, and when you add the exponents, that's where the 2 comes from. When you're multiplying binomials, remember a binomial is just a polynomial, that has 2 terms. So here we have a binomial being multiplied to another binomial. So we are looking at multiplying binomials. There are 3 ways you can look at multiplying binomials. Really, all of these ways are really just using the distributing property. So let's start with the distributing property. The distributing property basically is saying that we're going to multiply x times both of these. And when we multiply x times x, we get x squared. And then when we multiply x again times the 3, we get positive 3x. And then we're going to do the distributive property again, and this time we're going to multiply -2 times both of those. And when I multiply -2 times x, I get -2x. And when I multiply -2 again times the positive 3, I get -6. So that's just distributing x times both of those and -2 times both of those. And you should always combine like terms. And when you combine like terms, your final answer is x squared. A positive 3x and a -2x gives you just a 1x minus 6. And notice that our answer has 3 terms. And when you have a polynomial with 3 terms, that is known as a trinomial. So knowing some of the vocabulary words is helpful. So 3 terms is trinomial, 2 terms is binomial, 1 term is monomial. So let's do this problem over again using the acronym FOIL. FOIL stands for first side, outside, inside, last. It's really just the distributing property that we just did up here. All 3 of these really are just using the distributing method, right? Where we're just multiplying x times both of these. Then we're going to go back and multiply -2 times both of those. That is the distributing property. FOIL is really just a distributing property, but we like to mention it because it does help when we go back to working backwards and doing what's called factoring, understanding how to FOIL can be very beneficial. So basically, we're going to multiply the first ones together. So these two are the first in the parentheses. So that gives us x times x is x squared. When you multiply the outside ones together, that's the ones that are furthest to the outside. Those are your outside ones. So x times 3 is a 3x. When you multiply the inside ones, those are the ones that are closest inside. So negative 2 times x is negative 2x. So that's your I for inside. And the last ones are the last ones in the parentheses. And so negative 2 times 3 is negative 6. And we always should combine. So this is our first one. This is our outside. This is our inside. And this is our last. And I call this our OI because it's OI in FOIL. So that's our OI. Combine like terms, we've got x squared. Positive 3x and negative 2x leaves us 1x minus 6. And there is your answer when you multiply those two binomials together. And again, notice that that is a trinomial. So there's your FOIL. First side, outside, inside, last. Let's look at it from another perspective. Again, you're really just distributing, but this one is called generic rectangles. And some of you might have seen this in the past. It's just a technique to help you multiplying two binomials. So we're just going to write x and a negative 2 on one side and x plus 3 above. And we're going to build what we call a generic rectangle. We're going to put lines down through the middle of the two terms. And then we're basically just going to multiply x times both of these terms. So x times x is x squared, and x times positive 3 is 3x. Now we're going to do the same thing together, but this time we're going to multiply negative 2 times each of these terms. And that gives us negative 2 times x is negative 2x, and a negative 2 times 3 is a negative 6. And then we're going to combine like terms. So notice we have an x squared, but notice how these two terms both have plain old x's. So these are considered like terms, and we always combine like terms. So a positive 3x and a negative 2x is an x when you combine like terms. And then we have minus 6. So notice in each of those three different ways, you're really just distributing. And some people like to use generic rectangles. It's helpful. And then we like to use FOIL. So let's practice foiling and multiplying two binomials in the next slide. So let's multiply these two binomials by using FOIL, first side, outside, inside, last, which is really just using the distributed property and just multiplying 3x times both of these, and then multiplying negative 4 times both of those. But let's use the FOIL acronym to practice. So we're going to multiply the first ones together. So 3x times x is 3x squared. Then we're going to multiply the outside ones together, and that gives us 3x times negative 2. Wouldn't that be a negative 6x? And then we're going to multiply the inside ones together. Negative 4 times x is negative 4x. And then we multiply the last ones together. Those are the last ones in the parentheses. Negative 4 times negative 2 is a positive 8. So there is our first ones, our outside, our inside, and our last. And then combine your like terms, which is your OI, in FOIL, because they both have plain old x's. So our final answer is 3x squared minus 10x's plus 8. So that is your answer you get when you multiply those two binomials. Notice that answer has three terms, so your answer turns out to be a trinomial. Let's look at if we go back to number 1, we could have done it using generic rectangles, right? And then build, and then we're going to multiply 3x times both of these. That gives me 3x squared minus 6x. Then I'm going to multiply negative 4 times both of those. And that gives me negative 4x and a positive 8. Combine like terms. So my final answer is 3x squared minus 10x's when you combine like terms, and an 8. So just wanted to show you one more time how to use the generic rectangle technique. After that, I'm just going to use the FOIL technique. In example number 2, we have that x minus 5 is squared. Remember what this squared means. It means that an x minus 5 is being multiplied by another x minus 5. So when we FOIL and multiply the first ones together, we get x squared. When we multiply the ones that are furthest outside, we get negative 5x. When we multiply the ones that are inside, we get another negative 5x. And when we multiply the last in each of the parentheses, we get a positive 25. When we combine like terms, so remember this is our first side, our outside, our inside, and our last. When we combine like terms, we get x squared minus 10x's plus 25 when we FOIL. Let's look at the next one. Here we have x minus 3 times another x plus 3. So when we multiply the first ones together, we get x squared. Multiply the ones that are furthest on the outside, that gives us a positive 3x. When we multiply the ones that are inside, we get a negative 3x. And when we multiply the ones that are last in the parentheses, in each of the parentheses, the last ones, that gives us a negative 9. So again, that's our first ones, our outside ones, our inside, and our last. And when you combine like terms, what happens? That gives you x squared and a positive 3x and a negative 3x. Gives us no more x's, so we end up with x squared minus 9. Notice our answer in this particular problem turns out to be a binomial type answer because our answer only has 2 terms. Let me give you some problems to practice. Pause the video, practice a few of these problems, and then play it and see how you did. Okay, why don't you stop the video, copy these problems down, practice them, and come back and let's see how you do. So how did you do? On problem number 1, we are multiplying a monomial times another monomial. Did you get negative 16x to the 9th power? Let's see why you should get that. Remember, we're going to multiply negative 8, which are the coefficients, times 2. So that is where we get negative 8 times 2. And then we're going to multiply x to the 5th times x to the 4th. Do you see now where we get negative 16x to the 9th? Don't forget you add your exponents for the rules of exponents. What about number 2? Did you get 36x squared? Let's see why you should have gotten that. Remember, 6x is being squared, which means another 6x times another 6x. So we are multiplying the coefficients 6 times 6 together, and then we are multiplying the variables x times x, and that is why you should have gotten 36x squared. Let's look at number 3. In problem number 3, did you get x squared plus 6x minus 16? Let's see what would happen. If you multiplied the first ones together, that gives you x squared. If you multiply the furthest ones outside, is negative 2x. If you multiply the ones that are inside, you get 8x. If you multiply the last ones, you get negative 16. If you combine like terms, you get x squared plus 6x minus 16. Again, first side, outside, inside, and last. Let's try the next one. On the next one, did you get 10x squared plus 13x's minus 3? Let's check why that is. When we multiply the first ones, don't you get 5x times 2x is 10x squareds. When you multiply the outside ones, 5x times a positive 3 is positive 15x's. When you multiply the inside ones, negative 1 times 2x is negative 2x's. And when you multiply the last ones, negative 1 times 3 is a negative 3. When you combine the outside with the inside, notice combining like terms, doesn't that leave you with 10x squared plus 13x's minus 3 as your final answer. I hope you found this review helpful.